Hello, and welcome to the fifth and final video in this series. This is just going to be an extended demo of improving our dog-squirrel simulation using a lot of the tools we've learned and a couple of extra things to make our program complete. So there's no new slides in this video, but this is just showing you how we can apply everything, put it all together, and produce a product similar to what you'd produce in your project. But before that, I do want to just take some time to go over some citations. First, I want to give credit to Bhumika and Varda, who made a lot of these, or who made slides that these slides are based on for last spring. And also, I referenced a lot of these tutorials when making these slides, so feel free to check them out. There's a lot of other ones, but I like these. And there's many other resources online that you should check out if this tutorial didn't answer a question you have or didn't show you some feature that you want to implement. Okay, so with that out of the way, let's go to this demo. All right, here's our simulation as it currently stands. And just to remind you of what it does, so it loads a dog and a squirrel onto the screen. We can move the dog right and we can quit. That's pretty great, but it's not as great as it could be. There's a lot of things that you might want to fix about this program or you might want to improve, and we'll tackle a few of them in sequence. The first and most obvious one is that our dog can only move right. It should be able to move right, left, up, and down, depending on which key the user presses. So how do we fix that? Well, one solution would be to take this code here and just copy it 4 times and maybe change right to left and up and down and change some of the positions and 10 to -10, etc. But basically copy the code 4 times. But that's probably not a great idea. If you've taken one thing away from this class, hopefully it's that when you see a lot of highly repetitive code, you're probably doing something wrong. You shouldn't have a ton of repetition in your code. That's a sign that you should take that repetition and abstract it away into a function. And you can imagine if we also wanted to move the squirrel, then we'd repeat it 4 more times. And then if we add other animals, there's just going to be just an endless sequence of highly repetitive code that's unnecessary and burdensome to read and debug. So we're going to take this, and first thing we're going to do is rewrite this logic in a function. And you'll see that once we do that, it'll be much easier to make the dog move in all directions. So I'm going to start by just deleting this. Goodbye. Instead, we're going to go up here and create a function. All right. So what I'm going to do, and I don't expect this to be like the most obvious way to encapsulate this in a function, but I thought about it before and this is what I came up with. So just try to follow along. I'm going to create a function and it's called updateImage. That's what I want to do. I want to take this logic for updating the position of an image, basically animating it, and put it in this function. So I call it updateImage. And it's going to take 5 arguments. The first one is the image that I want to move, which makes sense. The second one is a rectangle that corresponds to the image. I have to know that to animate it. The third one's going to be a position, and you'll see why that's useful in a second. The fourth one is going to be the key. So I want this function to be able to handle all the types of behaviors that a user could input, going up, down, left, or right. So I'm going to allow that to be passed into the function, and that's going to be the key. And finally, change, that's the amount that we want to change the position. And we'll see how all this gets used as we write the body. But those are going to be my 5 arguments. And then I'm going to start by just filling the screen, screen.fill, fill it with black as usual, and we'll fill it only the rectangle. And notice that I didn't put dog rectangle, I put just rect, because that's the name of my variable, and this is going to be whatever rectangle I pass in. So if I was animating a squirrel, I could pass in the squirrel rectangle. I've made this more general. Right now I don't need to do that because I just have the dog, but I'm trying to make this as general as possible in case we want to add things later. So we'll do that first. And then we need to check for a few things, because I'm always going to fill the rectangle, but the way that I move the image is going to depend on what the key is. So I'm going to have a sequence of if statements. First, I'm going to say if the key is the left key, what do I want to do? Well, I want to first change the position of the image, and then I want to update the rectangle. Both of those things will be within this if condition. First, I want to change the position. How do I do that? Well, what we did before is we had the position stored in a list, and we had the position coordinates, x and y coordinates, of the upper left corner of the position of the image stored in a list, and then we retrieved that coordinate, one of those coordinates, x or y, depending on how we want to move, and we changed it. And that changed the position of the image, and then when we blitted it onto the screen, again, it would be in our new position. And then for moving the rectangle, we just moved it corresponding. We can do the same thing here, but instead of using dog position and dog rectangle, we're just going to use these generic variables that we passed in. So I'm assuming that position here is going to be a list of an x coordinate and a y coordinate, and that's a fine assumption to make because I'm the one writing the code, and that's all I'm going to pass into it. So I'm going to say position 0, because if I want to move left, I only want to change the x position, and the x coordinate is going to be the 0th item of this position list, as we've been seeing. And I'm going to say minus equals change. I'm going to change this by change. We passed in how much we want to change by. Before we were changing by 10. Maybe I want to change by something else. So I'll pass that into the function, and then we'll change position by that amount, and we'll subtract because we want to move left in the x-axis. Okay, so hopefully that makes sense. And then I'm going to update the position of the rectangle, which is simpler. I'm going to say rect.move IP, and the rectangle is whatever rectangle I passed in that corresponds to the image. And how do I want to move it? Well, I want to move it negative change 0. Why negative change 0? Well, remember these two arguments are the x change and the y change. The y change is 0 if I'm just moving left. And the x change is, well, change, whatever we passed in, but it's negative because I'm moving left on the x-axis. So it's just like up here I did minus equals, here I do negative change. Looks sort of weird to do a negative variable, but that works fine in Python. That's all I have to do if the key is left. So if the user wants to move our dog left or our animal left, this is going to effectively move it. But I have to handle the other cases as well. So we're just going to write some similar code for the others. So if the key is pygame.kwrite, then we're going to say position 0. Again, we're dealing with the x position, but here we're going to do plus equals change, and we're going to say rectangle move in place, change, and 0, not negative change. So that's for right. Then if the key is up, I want to move up. We did this before. Then we get the y position. We do minus equals change because of how the y-axis works. It goes from 0 at the top and the numbers get larger as we go down. And then we're going to say rectangle.move in place. Again, negative change. This time we want to move 0 in the x direction and negative change in the y direction, just like we did for the actual image position. And then finally, if key is pygame.kDown, then again we'll get the y position. Here we'll do plus equals instead of minus equals by change. We'll do rectangle move in place, 0, and positive change. And that encompasses most of the logic. We're just missing one thing now, and that is blitting the screen. So here I filled the screen, then I moved the image, I moved the rectangle, but I never updated the image on the screen. Users are not going to see anything yet. So I need to write screen.blit, and I want to put the image on the screen. That's why I passed in image as the argument. And I want to split this at the updated positions. That's why I stored the positions in a list, and then I can pass it into this function without any knowledge of what they were, update them in this list that's mutable and will change, and then just use the new values as I call to blit. So I'll just put position 0 and position 1. And this is all the logic we had before, just in a function. So it's a lot more general. It'll allow us to do some more powerful things, and that's about it. And notice that the one thing I'm not putting in here is pygame.display.flip. I'm choosing not to flip the display when I do this. I just want this to update the screen, and then I'll choose outside of this function when exactly to flip the screen and display things to users. Because if I want to change a lot of things at once, I don't necessarily want to be flipping the screen after each one. I might want to make multiple calls to this function and move multiple images and then flip the screen so the user sees all of them at once. So I'm going to leave that out. Now we have this helper function. That's great. Let's put it to use. So down here, where I have checking if the event type is pygame.keyDown, if it is in fact a key down event and the user pressed some key, I don't know if it's left or right or up or down, then I want to make a call to this function. And so I'm going to just call update image. And what argument should I pass in? Well, the first argument was the image, and that's going to be dog surface. That's where the dog image is. The second argument was a rectangle. That's dog rectangle, so it traces the dog. The third was a position list of the x and the y coordinate. That's going to be dog position. That's really why I stored position in this list up here, so I could eventually do this. Then a key, and that's going to be event.key. So whatever the event was, I'm just going to get the key, and that's going to be left, right, up or down, and that logic is encompassed in this function. And then my final argument is the change, and here I could write something like 10. I want the dog to move 10, but that's not necessarily a good idea, because what if I make multiple calls to this function in different places in my code as it gets longer? Then if I want to change the amount the dog moves, I'll have to go back and change each one. So I'm not going to do that. Instead, I'm going to go up here and create a variable called dog change and set it to 10. And now later, if I decide, oh no, my dog should move 20, or there's another level in my game where it moves 20, I can just change the value of this variable instead of changing it everywhere I make a call. So I'll just pass dog change in as the final argument. And now this function should work properly. This should do exactly what our code did before, but it should be able to handle not just moving right, but moving up, down, left, and right. We did it with a lot less repetition than we would have had to if we had just hard-coded. This function's actually still a bit repetitive, and you could actually even make this better, and I encourage you to think about how, but it's certainly better than what we would have gotten if we did it down here. Now let's look at what we have. You'll see that I pressed keys and nothing happened. Why did nothing happen? Did I write this function wrong? No, I did not write this function wrong. We forgot a crucial step, which is flipping the display. I chose not to do that inside of this update image function, so I need to do it outside. So I'll add pygame.display.flip. And now my code, no, I will not purchase. Now my code should work as I want. Great, that was fun. So now our dog can move all around. This is getting more and more realistic. We have a dog that can move everywhere, but and chase a squirrel, but the squirrel can't respond. That's not good. Normal squirrels don't just sit there and get chased, they run away. So we need to make our squirrel move as well. And with the function we've written and the images we've set up, this will be pretty simple. We'll only have to add a few lines of code. The first thing we'll have to do if we want to animate our squirrel is add a rectangle that tracks the squirrel image. So we'll do that up here, just as we did with the dog. Create squirrel rectangle variable. And I'll set this to initializing a new rectangle. the arguments will be squirrel position 0, squirrel position 1, squirrel surface get the width, and squirrel surface dot get height. So you'll notice that this corresponds exactly to how we created the dog rectangle. I'm not going to walk through what each of these arguments are and why they make sense, because they correspond exactly, and I did that in the previous video. So if you're still a little confused about what this means, you can go back to that. But all I'm doing is initializing a squirrel rectangle. And then I want to come down here and add squirrel change, because I have the amount that the dog changes. I know eventually I'm going to use this update image function, and the squirrel is going to change by some amount. So I'm going to add this variable squirrel change, and I'll say the squirrel should change by 30 instead of 10 to make it hard for our dog to chase it. So we have that. Then we'll come down here and make our call to update image. What image do we want? Well, that's the squirrel surface. What rectangle? Well, that's our newly created squirrel rectangle. What position? Well, that's the list of squirrel XY coordinates. What key? I don't know. I believe this is question marks for now. And what change? Well, that's obviously squirrel change. All right, so what key? Well, here we just want to think about how our game works. And maybe this is a two-player game, or maybe the player also controls the squirrel, but I'm going to say that the squirrel is controlled by the computer. So the computer is going to choose which key. It's not event.key, because the user doesn't enter it. It's just going to be some key. And maybe I could have some complex algorithm that tries to run away from the dog, but for this demo, I'm just going to say the squirrel is going to move randomly. All right, so how do I make the squirrel move randomly? Well, I'm going to do a couple of extra things that were not in the slides, but I don't think are too hard to understand. What I'm going to do first is import another module, Pygame's random module, which is useful when you want to do something random. And I'm going to add up here another variable called keys. And that's just going to be a list of all the keys, because I'm going to want the computer to continuously choose a direction. Choose up, down, left, or right, and in order for our code to work properly, it's going to need to choose one of Python's names for these directions. So we'll do pygame dot k underscore down, that's down, pygame dot k underscore up, which is up, whoa, up, pygame dot k underscore right, and pygame dot k underscore left. So now I have all the directions in a list, and now what I can do is just have the computer, every time the squirrel moves, choose a direction from the list randomly, and then make the squirrel move by calling update image. So the key argument here, I'm going to get rid of these question marks, and I'm going to pass in random, that's the random module, dot choice. This is a function that chooses an item randomly from a list, and the list I'm going to pass in is keys. So random.choice keys, that's not something we learned about, but that's just going to randomly choose a direction. And now you'll also notice that every time the user presses a key, the dog will move, update image with dog, and the squirrel will also move randomly. So whenever the dog moves, the squirrel will move in a random direction as the dog tries to chase it. Now, once again, let's look at what we've created. We're getting better. So now we have a squirrel that sort of runs away from our dog randomly, and the dog can try to chase it. We don't just have to move in a straight line, we actually have to think about how to catch the squirrel. We're getting steadily better. There's still a problem. If you noticed, as we got toward the end of that, when the dog got close to the squirrel, they just started covering each other up, and it got really weird, and that's probably not the behavior we want to have anyway. If we want a realistic demonstration of dog-squirrel interactions, then when the dog catches the squirrel, this needs to stop. That's game over, the game is done, the squirrel has lost. So that's the final thing we're going to add in this demo, is making our code stop when the dog catches the squirrel. In order to do this, we're going to need to use a few features of Pygame that I didn't demo in the earlier slides, but they're not too complicated. And I think it's good to see how we can use these, because probably in whatever game you're creating, you're going to need a little functionality of Pygame that I didn't cover in this tutorial, and it's not too bad to just look up some of the docs, find the functions you need, and then add them to your code. So we'll do that here, except I'm going to skip the part of looking at docs because I already did that. So how we're going to do this, Pygame has a function called collideRect. CollideRect stands for collide rectangle, and that's going to check whether one rectangle has collided with another. So down here, you can write if dog rectangle dot collide rect, and I'll pass in an argument squirrel rectangle, and this just says if the dog rectangle has collided with the squirrel rectangle, if these are touching. And that makes sense. That means that our dog and our squirrel are touching. And notice that I use the rectangles, not the images, because it can be difficult in Pygame to tell whether two surfaces imposed on another surface are touching. But it's very easy to tell whether two rectangles are touching. So here we're using the rectangles that, as we've been saying, directly correspond to the surfaces or the images. So if the two rectangles are touching, I know that the user has won the game, has found the squirrel. What do I want to do? Well, a simple thing I could do is just say running equals false. Say running equals false, and then that will end this game loop, and Pygame will quit, and my game will end. That's perfectly valid. I'm going to do something slightly more convoluted, not because it's better, but because I want to show you how to use another feature of Pygame. So another way I can do this is create a variable end, and set it equal to pygame.event.capital-event pygame.quit. What in the world did this do? This created an event. And I'm showing you this not because, again, this is the best way to end our game, but because you might want to create events in whatever game you're implementing. So the way you create an event is you do pygame.event.capital-event, and you pass in the type of event you want to create. So here I create a quit event, that's what's returned by this method, and I store it in the variable end. Well, that's great, but that's not going to end our game, so we need to do one other thing. We need to write pygame.event.post end. Now what does this do? Well, the post function, pygame.event.post, will take in as an argument an event. Here we have end, which is a quit event that we just created, and it's going to add it to the end of this event list. So normally events are just collected automatically by Pygame. The user does something and they're collected. But sometimes you might want to add an event to the list. Like maybe you want to simulate the computer doing something and you realize the best way to do that is to create an event and add it to the list. Pygame allows you to do that. You just call this capital event initialization function with the event type. You store the event as a variable, and then you can pass that to this post function, and it'll add it to the end of this event list. And then Pygame will process it just like any other event. So what is the end effect of the code we've written? Well, it does the same thing as that simpler code I wrote a second ago. It creates a quit event, then it adds the quit event to the end of the queue, and then when the quit event reaches the front of the queue, it'll be processed, and running will be set to false, and we'll exit out of the game. And now, if we once again view our work, we'll see that it works as desired. As soon as our dog reaches the squirrel and has caught it, our program closes. And so we're done. Now let's try this again with a different strategy. What if we try to be sneaky as the dog? So you can see in that demo that didn't work very well. If we try to be sneaky as the dog and sort of take too long getting to the squirrel, then it'll randomly move off of this display. That's one thing that we didn't implement, checking for whether the squirrel hit the boundaries, and that's something you probably would want to implement if this was your actual project, but for now I'm just going to leave that be and leave it to you to figure out how you would do it. It's not too tough. There's also other functionality that you might want to add to your project. For example, if you had a background that wasn't just a solid color and you wanted to animate images over that, you'll have to do a little bit of extra work to make sure that your background image doesn't get erased when you move your rectangles and surfaces. And there's various other things, little refinements that we didn't cover in this tutorial. But my hope is that this provides a good foundation for what you can do on your own projects, that you can build on this or take certain features as you'd like, and also provides you some guidance on how to think about solving problems and factoring your code in an effective way. That's all from me. Best of luck on your projects, and of course, have fun.